Hello friends, I'm Rituvish. Today I will discuss very important topic of statistics, that is correlation. Students are generally confused in the formulas while calculating correlation. We generally experience interrelationship among variables, especially in economic science and social fields. Price increase with increase in demand of goods. Tall father have a tall son. Capital invested and profit earned. They are the variables, they are all interrelated. So we can say when two quantitative facts have a cause and effect relationship and vary simultaneously in same or in opposite direction, the measurement of such variation is called correlation, and symbol of correlation is R. In statistical analysis, the correlation is widely used because of its more reliable forecasting that helps in reducing uncertainty in decision making and leads to more reliable forecasting. It also helps studying economic activities, that is, the impact of changing price on changing demand, changing supply of money on the price of money. And it also helps in estimation of other variables on the basis of one variable, provided the variables are interrelated. For example, the share prices at Delhi and Mumbai Stock Exchange are interrelated. So, at the basis of prices at the Mumbai, we can estimate the prices in Delhi. It also helps in useful in research field, that is, in helping drawing conclusions and developing hypotheses on the area of research and investigation. There are three types of correlation: positive and negative correlation, linear and curvilinear correlation, simple, multiple, and partial correlation. In positive and negative correlation, when the two variables deviates in same direction, that is, increase in value of one variable leads to increase in the value of another variable, and decrease in value of one variable leads to the decrease in value of another variable, this is called positive correlation. For example, price of commodity and quantity of commodity supplied, height and the weight of growing child. And negative correlation, when the two variables deviates in opposite direction, and vice versa, this is called negative correlation. For example, decrease in the demand on increase in price of the commodity, decrease in the sale of woolen clothes on the rise in temperature. Linear and curvilinear correlation is based on the ratio of change between two variables. When the ratio of change between two variables is constant, this is called linear correlation. That is, rise in the price by 10% of a commodity every time will lead to fall in demand by 5%. This is linear correlation, and mathematically it is calculated by y is equal to a plus bx. And in curvilinear correlation, the change in variables is not constant, it fluctuates. That is, rise in price of a product by 10% will lead to fall in demand ranging from 5% to 20%. In simple, multiple, and partial correlation, when the correlation between two variables is studied, this is a simple correlation. When more than two variables are studied, this is the problem of multiple or partial correlation. For example, factors like rainfall, fertilizers, agricultural production, different factors have different impact. In multiple correlation, when one is dependent variables and others are independent variables, and we study the impact of independent variable on dependent variable, this is the multiple correlation. And when we study the impact of independent variable on dependent variable, keeping all other factors constant, this is a partial correlation. And we will study the concept of multiple and partial correlation further in detail. When the movement between two variables is in same direction and in same proportion, this is the perfect positive correlation and denoted by +1. On other hand, if changes are proportional but in opposite direction, this is perfect negative correlation denoted by -1. And when there is no interdependence of the variables, that is absence of correlation, that is correlation is 0. The relationship between perfect correlation and absence of correlation is the case of limited degree of correlation. It may be positive or negative. The positive degree is there when it varies from 0 and 1, and negative when it varies from 0 and -1. Methods of determining correlation are graphical method and mathematical method. Graphical method involves scatter diagram, correlation graph. Mathematical method involves Karl Pearson's coefficient of correlation, Spearman's rank coefficient of correlation, and concurrent deviation method. Scatter diagram is the most simple method of estimating the degree and direction of correlation between two variables. When all points lie on a straight line rising from left hand corner to right hand corner, there is perfect positive correlation, and when all points lie on a straight line falling from upper left hand corner to right hand corner, there is a perfect negative correlation between two variables. And when all points are plotted on a scattered manner with no definite trend, that is an absence of correlation. That is, there is no correlation between the variables. The famous biologist and statistician Carl Pearson gave the most widely used method of measuring correlation. Since it gives both precise and clear direction and degree of correlation, it is widely used. Carl Pearson has given two methods of calculating coefficient of correlation. One is direct method, other is shortcut method. Friends, direct method is used when arithmetic mean is in whole number. Formula uses sigma dx dy divided by number of observations into standard deviation of x into standard deviation of y. That is further concluded as sigma dx dy divided by number of observations into square root of sigma dx square divided by number of observations into square root of sigma dy square divided by number of observations. That is further concluded as sigma dx dy divided by square root of sigma dx square into square root of sigma dy square. So the formula is precisely explained in the example here. Here are two series. You can see birth rate and death rate. Birth rate is taken as X series, death rate is taken as Y series. Friends, you know very well, correlation is calculated when there is one independent variable and one is dependent variable. So take birth rate as an independent variable and death rate is a dependent variable. In the first column of birth rate X series, sigma X, that is sum of all the observation in X series, equal to 180 degree. And to find the mean, sum of X series, the observations is divided by number of observations in the X series, that is 180 divided by 6 is equal to 30. So sigma X, mean of X is equal to 30. Now deviation of X taken in second column is calculated as X minus mean of X, that is 24 minus 30, 26 minus 30, and sum of deviation of X is equal to 0. Friends, be careful, deviations of X or deviation of Y should always be 0 and arithmetic mean should always be in whole number. Then only you can calculate the correlation by direct method. Otherwise you have to follow the shortcut method. Then another column is deviation of X square. The sum of deviation of X square is equal to 90 degree. Now next is Y column, death rate. The series is calculated and sum of the series sigma y is equal to 132. Now mean of y is equal to sigma y divided by number of observations in y series, that is equal to 132 divided by 6 is equal to 22. Now deviation of y, again y minus mean of y, 15 minus 22, 20 minus 22, and sum of deviation of y is equal to 0. Now square of deviation of y, and last column is dx dy, that is deviation of x multiplied by deviation of y, that is minus 6 minus multiplied with minus 7, that is equal to 42. Now sum of deviation of x and deviation of y multiplication is equal to 81, that is sigma dx dy is equal to 81. So putting the formula further, it is correlation is calculated as sigma dx dy divided by number of observations into standard deviation of x into standard deviation of y. So friends, standard deviation of x is calculated at sigma dx square divided by number of observations ka square root, that is square root of 90 over 6, that is 3.87. And same is with standard deviation of y, square root of sigma dy square divided by number of observations, that is square root of 86 divided by 6 is equal to 3.79. So correlation is calculated as sigma dx dy divided by number of observations into standard deviation of x into standard deviation of y, that is equal to 81 divided by 6 into 3.87 into 3.79, and your answer will be plus 0.92. And another last formula we concluded earlier was sigma dx dy divided by square root of sigma dx square into square root of sigma dy square, that is equal to 81 divided by square root of 90 into 86, that is equal to 81 divided by square root of 7740, that is equal to 81 divided by 87.98, and your answer will be again plus 0.92. That means you have got a positive correlation between the variables. So friends, I hope the video very well clarified all your concepts regarding correlation. In coming video, I will explain the shortcut method of calculating correlation, and in my coming videos, I will be clearing all your concepts of statistics like index number, multiple correlation, partial correlation, regression, and many more. So do like and subscribe my video. Thank you.